coming. Thanks for being here today. And today I'm gonna talk a little bit about the work that we're doing at Scalvy and the different applications for it. And happy to have this more of a discussion and answer any questions that you might have. All right. So Scalvy is about a year and a few months old startup focusing on building modular electric powertrains. We define electric powertrains or electronic powertrains as the electronic and the software that goes from the battery all the way to your motor and all of your loads. Because in every electric mobility application, you're not just driving a motor. You also have auxiliary loads. You have HVAC systems. You have electronics, navigations, entertainment in the vehicles, and the load of these auxiliary systems is exponentially going up year after year because of the more need for entertainment, more need for navigation, more need for engagement inside the vehicle, and the need to power many processors to be able to do that. So at the end of the day, our modules are sitting in the middle between your battery and your motor and your other loads and your charging, because at the end of the day, you need to charge these applications. The point that is differentiating us is that we are not building a system that's gonna be project per project basis. What do I mean by that? We found that there is a real need in the industry for a powertrain solution that can enable low volume OEMs, low to mid volume OEMs. So if you look at passenger vehicles right now, if you look at Ford or GM or Volvo or others, to be able to reach economy of scale and to be able to reduce the high cost of electric vehicles that they are producing, they have to really produce in large numbers. We're talking about tens of thousands, as even hundreds of thousands of units of every EV model every year. So that's a kind of size that they need to be working at. But the problem with that is that it's leaving the low to mid volume market underserved, really. So try to speak to some of the largest tier one suppliers, Delphi, BorgWarner, Magna, Valeo, and others, and try to tell them, hey, I have 100 vehicles or 500 vehicles or 1,000 vehicles that I'm trying to electrify. I need electrification solutions. I need an inverter, a DC-DC converter, onboard charger. Yeah, they're not interested. They're not interested in this space at all. They're not interested in this volume at all. And as every industry matures, the need for platform and for modular solutions becomes apparent. And that's where we are right now in electrification. There is a real need for a platform solution, for a modular solution that can work across different vehicles, across different vehicle types, across different customers. And that's what we're building here at Scalvy. In a way, what we are doing is that we are commoditizing the hardware so that we can use it across different applications and reduce the price for every single customer, and so that we can serve low and mid volume customers, and then differentiating between them on the software side. So for example, depending on the kind of battery storage you are using, the motor you are running, all of that is going to affect the software algorithms that we deliver as part of the integrated solution. So in a nutshell, we're providing modular and scalable solution for low to mid to high volume markets, because we also have huge advantages in the high volume markets, as we're going to talk. Simpler integration, faster development, and lower cost. All of this is really what a modular approach can achieve. So what actually goes into it? And if the video is on, I would have shown you a photo of one of our modules live, but we're gonna see a couple of photos for it. So what goes into it? We call it SIM, for Smart Integrated Modules. Inside every SIM, there are basically 3 layers. The first layer is the battery management system. which does everything starting from SOC estimation, SOH estimation, balancing, management within every module and within a number of cells. And then the second level is the converter, inverter, charger. That's basically the power electronics level. That's the inverter that's going to feed into your motor or motors. That's a charger that can get fed from the grid. And that's a DC-DC converter that's going to provide regulated DC output for your auxiliary loads. And then finally, the controller or the software algorithms, the modular software algorithms that we are using here. These modular software algorithms are designed so that every single board is locally controlled. Every single board is not waiting for an action from a master board to tell her what to do. Every single board looks at its own local measurements and takes immediate actions. And that's something very important for higher efficiency, for higher reliability, and for better safety. So the main thing that our technology is achieving is rapid development, lower cost, and simplified supply chain. And for simplified supply chain, I can ask you that we can do a very quick exercise. If you go to any one of the largest electronic distributors' websites, let's say DigiKey or Newark or Mauser, and try to find MOSFETs, probably it's going to have to be silicon carbide, that are working in the range beyond the 1000 volt, let's say 1200 volt, and working in the current beyond 300 amp. Why are these numbers important? Because these are the numbers that would enable you to build an electric vehicle in the 150 to 250 kilowatt range at an 800 volt DC bus. Because that's really is becoming the standard now. Going to the 800 volt DC bus is reducing the weight of your powertrain, reducing the cables, increasing the efficiency. So the industry is certainly going there. So if we do this exercise, you're going to find that there is very limited availability on what's out there in the market. And that's part of the complicated supply chain, that everyone is trying to electrify at the same time. So there is huge pressure on certain subcomponents that need to go into the system. One of them is the silicon carbide FETs. Another one is high voltage, efficient bulk capacitors. What are the bulk capacitors? If you look at the incumbent powertrain solution, you're going to find that there is what's called the high voltage DC bus. This high voltage DC bus is basically a group of tens or hundreds of capacitors connected in series and parallel configurations together so that they can support the motor load by providing a stable DC bus. These are also under huge pressure right now in this industry. So getting out of this complicated supply chain is a goal by itself. And that's what we're trying to do here at Scalvy, because we don't need high voltage DC buses. We don't need silicon carbide FETs. Why is that? So let's look here at a comparison between a conventional system and our system at Scalvy. In the conventional system, you have the battery modules connected to battery management system modules and battery management system master, connected through high voltage, high current cables to reach the high voltage DC bus. You have the onboard charger with its own filters, the DC-DC converters that are going to give you the DC loads, and then the motor drive unit, which is going to run the motor with its filters. So all of that is part of that's a very simplified powertrain configuration. But if you look here at the right, what we're doing at Scalvy is that we can completely get off this high voltage DC bus because we don't need it anymore. Because now you can think about the batteries. If you embed the powertrain modules into these batteries, you're transforming these batteries into smart batteries that can give you AC output, can give you DC output, and can accept charge and can balance the state of charge between its modules. And that's what we're doing here on the right. So completely getting rid of the high voltage DC bus is a huge win. The other thing is that in the motor drive unit, that's where you usually always find the silicon carbide MOSFETs, and there is no need for silicon carbide MOSFETs in our system. So beside everything we mentioned, we are able to save our customers 6 to 8 months of integration or more. Plus, even the development of the powertrain itself is much faster. We're getting it down from 3 years of development into under 1 year. Lighter weight and lower size. As we're going to see a little bit more details about that. We're saving more than 50% of the system conventional losses because we basically don't have any switching losses in our system. The powertrain losses or the inverter losses are coming from two main factors. The conduction losses, and there is no way around the conduction losses. The conduction losses is just the current going through your circuit and generating heat because of the resistive nature of the wires, of the MOSFETs, of everything. So there is no way around it. But the one thing that we can control are the switching losses. And our switching losses are less than 10% of the conventional system switching losses. As I mentioned, we are proud to provide nearly insensitive pricing model. So we're working with a large number of customers, starting from low volume customers who are only looking to electrify tens or hundreds of vehicles, all the way to off-road vehicle customers, to high volume customers in different regions of the world. And we're able to provide all of them a highly insensitive pricing model because we are always able to build a uniform hardware system that can be used across different customers and different applications. One of the biggest advantages of our system is that we can provide charging, bidirectional charging at any voltage level. And that's something that's missing in the industry right now. So right now, even the electric vehicle companies that are marketing V2X, meaning that the vehicle can charge your home, or the vehicle can charge your load, or the vehicle can be used as a portable power supply, even them, they are going to limit it to what kind of voltage they are going to provide to your system. In our case, we can really provide any voltage level because we have full control over the voltage and the controllability of the voltage that's coming out of our battery pack. So that's how the system would look like for an electric vehicle. You have a number of battery modules. On top of them are our SIMs or powertrain modules connected to a motor. You can have multiple motors in the front and in the back. We have more advantages. The more motors you use, the cheaper our system becomes compared to the conventional solutions. And that's here for a truck or an SUV. If you have multiple battery packs, what's going to happen? So you can easily still use the SIMs. You can even dedicate one battery pack for every motor. And this solution is advantageous for electric buses and electric trucks with long chassis, because the longer your chassis and the body of your vehicle is, the more expensive your cables are going to be. So if you are able to dedicate a battery pack for every motor, that usually saves our customers a ton of money. As I mentioned, so when we talk to any customers, any OEMs, the very first gating factor to decide whether this technology is useful for them or not, the very first one is the price. So you have to prove that you're competitive, if not cheaper than the current prices available in the market. But the very second one is the efficiency. So after you prove yourself on the price, you have to prove yourself on the efficiency. And we're proud that when we speak with these customers, we usually tell them, just show us the efficiency curves that you had from the last powertrain, from last designed powertrain for you. And we are always seeing that we have improvements in about 40 to 60%. largely due to what I mentioned before, which is that we mostly don't have any switching losses in our system. This is the weight of our system. So that's one of our modules. I promise you're going to see a photo. You're going to see another photo without the packaging. It's less than 4 ounces. It's actually about 3.5 ounces. Now that you don't only need one module, you're going to need probably tens of them. But even if you use 20 or 30 of them, we compare that to the conventional system, and we found that we're actually reducing the weight by more than 65%. And because we're not comparing ourselves only to the inverter, if we're comparing our system to the motor drive inverter, we are at about 50% weight. But you have to take into consideration the inverter plus the DC-DC converter plus the onboard charger, because we're replacing the 3 of them, plus the battery management system. So it's really quite advantageous in this manner. Another thing that I forgot to mention here is that when you look at how our configuration looks like on top of an electric vehicle, and if you're familiar with what's called zone control in what they call software-defined vehicles, the idea of zone control is that you don't take the decisions centrally in one location that is far away from its own application. So for example, in the battery management system, in the motor drive unit, it had been always used that you have one controller for the inverter, one controller for the BMS, and they share some messages between them. But really, every single one of them is controlling its own system without optimally trying to control the full vehicle. But in our system here, because of our distributed way of controlling, we are actually applying zone control on every single module that it can take action based on its own local measurements. So it's a distributed form of control. One thing we do when we work with our batteries and when we involve our battery management system features is that we find that we are able to extend the range of the vehicles that we are working on. And that's because conventionally, you always have the weakest cell or the weakest module is controlling all of your action. So actually your vehicle range stops not when the full battery pack is depleted, but when you have a group of modules or cells that are depleted enough that you cannot sustain running the vehicle any longer. Which means that the weakest cell and the weakest modules are the ones controlling your range. And that's not something that you're happy about, because at the end of the day, you're trying to extend your range and you would like to have all of them running at similar capacity, at similar SOC. But that's not what's happening in any electric vehicle. And the older the electric vehicle becomes, the more degradation it sees, the more evident this problem is going to be. Finally, here, that's a photo of one of our modules. That's about 2 designs ago. And that's how small it is. That's how it looks like. And that's here us in our lab when we were doing some prototype testing. That's in our Sunnyvale facility. We started the company in the Bay Area in California, specifically in Mountain View and Sunnyvale. And right now we're moving a big part of our team into Austin, Texas. We're building a new research lab facility here so that we can develop our powertrains further and start doing our in-vehicle integration testing. And that's it. That's really what I have for you today. This is a setup and a prototype that we built in one of our most recent events. It was Move America here in Austin, Texas, where you can see that every battery module is connected to one of our powertrain modules or SIMs, and they are connected together to provide power to the load. And what we were showing here is that we used to show people the state of charge balancing, the voltage and the current going to the motor, and so on, so that we can see that no matter what your load is, no matter what your states are, I'm always able to balance my state of charges, my state of charge levels of my modules. And at the same time, I'm always able to provide pure output electrical signals to my motor without the use of any additional filters. And that's it. That's here my email address if you want to reach out with any questions or any comments or any further discussions. Amr is our CTO. He's currently traveling to visit one large OEM in Germany. But yeah, happy to have a discussion with you and answer any questions. Let me see if there is anything I can mention. That's here a little bit more detailed brochure that I usually use with people if they have more technical questions, but it's mostly more or less it's covering the same technical details, just in a little bit more detail about reliability and safety, our BMS functionalities, etc. And our one pager is describing in more details the 3 levels of technology that we have here, starting from BMS, power electronics, distributed controllers with AUTOSAR compliant software algorithms. I'll stop sharing now and see if there are any questions that I can answer. So I have the first question is, is the chat? Yeah, okay. So I have the first question is from Arash Rojani, is that what is your estimation about how many years, for example, for a truck, we can use the batteries before exchange them? So we're not really working, I wouldn't call Scalvy that it's a battery technology company because we're working on the electronic side. So I think a battery supplier would be able to answer that better. But what we have seen from the first developed electric vehicles is that they can live for 15 plus years, right? Depending on the use, depending on how you charge them has a huge impact on them. Depending on how you balance them, depending as I mentioned, are you gonna stop your truck when one of your modules reaches end of life, while still you have 19 other modules that are not reaching end of life? So there is a huge industry that comes after the retirement of your batteries. What's gonna happen to them, right? Oh, I'm able to open my video now. So I don't know. I hope you guys can see me now. So there is a huge industry about what's gonna happen at after the retirement of the batteries. They're gonna be used in stationary applications that are less critical of their state of health. But yeah, they can live a long time if they are taken care of. How are you reducing the switching losses? Is it Kundan? Yes. So the first question I got from Kundan, he said 3 questions. How are you reducing the switching losses? So the switching losses are reduced because everyone, and I hope you guys can see our modules now. That's it. That's how big it is. Our newest ones are even smaller. The switching losses are reduced because every one of our powertrain modules is essentially seeing low voltage. And so none of them is seeing anything higher than 60 volt. And the way that we're switching them on and off is unique, and it's patented to reduce their switching losses further. So we're able to get the purified signals that we need, but without the switching losses that are that are always associated with these kind of signals. Can you please share the link for the detailed manual you just showed? Yes, I'd be happy to. If you can send me an email after the webinar, I'll be happy to share this manual. A slide showed that the motors are low voltage with the losses increase in the motor due to the low. No, the motors are not low voltage. The motors are still high voltage. We're actually able to run motors at higher voltage levels than the current industry, because I'm not limited to the limitations of the available commercial silicon carbide MOSFETs. I can actually go not just at 800 volt, I can go to 1200 volt and even more. Yeah, so we're not limited to that. we are able to increase the voltage more and reduce the current further. But yeah, I don't think there is a slide showing that. Maybe it was a misunderstanding. I think, yeah, there is another question. What's your vision for the thermal management of powertrains, especially since they are distributed? So what I can tell you so far, we didn't really need anything more than just an airflow. We're not using liquid cooling so far. We didn't yet reach the levels of 300 kilowatt and more. We're at about slightly less than that. But so far, we didn't need that. But even in conventional inverters at our levels, you always need liquid cooling. So the short answer is it's easier. It's an easier thermal management problem to solve because the power is distributed, so the losses are distributed. But at the end of the day, we are an electronics and software company, so the thermal management usually falls on the integration party, whether that's an OEM or that's a system integrator. So there is always a collaboration towards this, but it's very evident that it's less lossy than conventional systems. How long will it take? Another question is, how long will it take to discharge and charge? I'm not sure about the answer, but it takes as long as the conventional system. So we are actually following what the OEMs are requiring. So usually the OEMs are going to tell you, we need these batteries to work at 3C rate for that many minutes, 10C rate for that many seconds, and so on. So we're just following that. So we're basically sizing our powertrain modules to sustain all of these needs of the OEMs. The advantage that I can mention here is that when you're charging your system, there are basically right now, let's talk about the three main levels of charging: level 1, level 2, and level 3. Level 1 and level 2 are onboard charging technologies, which means that you need to have the onboard charger as part of your vehicle. And that usually goes up to 11, 15, 20 kilowatt. That's it. So 20 kilowatt is something that can take 4 to 6 hours to charge your vehicle, depending on the capacity of your battery, of course. But then in our system, our onboard chargers can take me all the way to 200 kilowatt and more. So I can actually use my onboard chargers for much higher power ratings. Why is that? Because I don't need a dedicated onboard charger, and my onboard charger is embedded in my modules. Another question, it looks like the number of SIM modules is dependent on the number of battery modules. Is this correct? Or can we use multiple SIM modules as needed for one battery module? From Zefan. So the number of SIM modules they look like they are dependent on the battery modules, but it's actually more about the voltage that you want your motor to operate at and the number of cells that you're using in your system. So in many technologies, you have cell to module to pack, meaning that we can go to an OEM, he can tell us, you know, guys, I have 30 modules in my vehicle. Can you work with that? And yes, we can. So the easiest way is to just plug every one of our SIM modules to one of the battery modules, and that's it. But then another way to do it is that there is also cell to pack directly. So cell to pack, meaning that I am the one who's deciding what constitutes a module. The module for me can be 4 cells connected together, can be 6, can be 8, can be 16. I can put more in parallel. So that's always made as a decision based on the OEM requirements. So yes, you can use multiple SIM modules for every battery module. What we usually end up doing is that we use one SIM module for every battery module. But if the current is so high, we can start building parallel circuits within the module. What is your company precautions for humid and wet climates about protecting these devices in very humid areas? So we have a packaging, again, where we're focusing on the electronics and the software of our solutions, but we have a packaging, electronic packaging company that we're collaborating with who are working more closely with this. But our first set of customers, But actually global. We have US-based customers, we have Indian-based customers, we have customers in China, in Europe, and in the Middle East. So we're doing a ton of testing in different climates with our partners. So yeah, but again, we're not the ones who are doing the electronic packaging. We're relying on our partners for that. When you're a startup, I think you should always focus on what you are best at, and that's what we're focusing on right now. All right. Any other questions? I think we answered everything. But again, you guys have my email address. I think Brian sent it here in the chat. So feel free to reach out to me anytime. And yeah, would love to stay in touch. All right, Brian. Thanks so much.
Sure. Thank you so much, Mohammed. That was great. And yeah, if you have any more questions or want to learn more about Scalvy, please reach out to Mohammed at the email as posted in the chat. And we'll be sending it as well as this recording and a follow-up email to you all. So feel free to reach out. And thank you again, Mohammed. That was fantastic deep dive into Scalvy and also great hearing you deal with the questions.
All right. Appreciate it, Brian. Have a great day, everyone. Bye-bye.
Thanks. Take care, everybody. Bye.